Hi, everyone. Thank you so much for coming. I'm Clara Moskowitz. I'm an editor at Scientific American magazine, and I'm happy to introduce today's Science on the Hill event, brought to you by Springer Nature Group, Nature Portfolio, and Scientific American. So today we're going to be talking about the problem of space debris and what we, and especially you, can do about it. There are more than 200 million pieces of trash currently in orbit that are capable of doing damage to an operational satellite if they hit it. And almost 30,000 of them are larger than a roll of toilet paper. And the risk isn't just to satellites. Only 2 months ago, a piece of junk from the International Space Station fell through the roof and 2 floors of a house in Naples. With the whole space station due to become trash in 2030, it's time we got serious about the waste in space. So we hope this panel will be an important chance to bridge the worlds of science and policy and make sure that the findings, knowledge, and insights generated by research can reach the people like you who are helping to make decisions that affect all of us. We want to better understand what policymakers need from the research and academic community. And we also want to show how policies based on peer-reviewed, published evidence are the most effective. So with that, I'll turn it over to our panel of experts. Morib Ajah is a professor of aerospace engineering at the University of Texas at Austin, as well as the lead for the Space Security and Safety Program at the Robert Strauss Center for International Security and Law. Michelle Hanlon is the executive director of the Center for Air and Space Law at the University of Mississippi School of Law, and the co-founder and president of For All Moonkind, a nonprofit focused on protecting human cultural heritage in space. Finally, we have Brian Whedon, who leads the space policy and regulatory team at the Aerospace Corporation Center for Space Policy and Strategy. Until recently, he was the chief program officer for the Secure World Foundation, a nonprofit working to safeguard the secure, sustainable, and peaceful uses of outer space. And our panel will be moderated by my fellow senior editor at Scientific American, Lee Billings. And with that, I'm just going to switch this screen that you're looking at over to a handy live map of all the pieces of man-made objects that are in orbit right above us at this very moment. You can come on up, Lee.
Now, does that include space junk up there? Or
Yep.
Just, okay. I kind of want another color coding here. Going to be distracted. Thanks for showing up today. Thank you to our panelists. I thought I was going to be sitting beside you, but now I'm at this lectern kind of feeling like an interrogator, but hopefully it'll be more of a conversation. I think I want to start out by just asking how we got here. What is the current status? I mean, I know that there's a lot of ways to slice that, but this figure that I've seen thrown around, for instance, about how we might have up to 50,000 new satellites orbiting the planet in less than a decade, by 2030, that's just, it's hard for me to wrap my head around that and how that rate of change is going. So could I get some of that from you right now, from anyone who wants to start, about how we got here, how it's changed in the past 10 years or so?
Well, I can get it started. Good morning or good afternoon, everyone. I mean, look, the big issue here is space is useful, right? There's a lot of societal benefits, many different categories that we can derive from space and have derived from space. And what we're seeing is more and more countries realizing that is the case and wanting to get involved. And then there's also a growing commercial space sector that we're seeing. And so you have this 50 plus years of previous space activities, which created a bunch of useful activities, but also a bunch of space debris. And then now we're seeing an accelerating growth, I would say, in new things coming online. And the question is where all that's going to go in the future. So you've got all kind of the historical activities and the historical space junk, and then a bunch of current and growing number of operational satellites that's going to be scaling up into the future.
And to work off of that, when you think about space and you think about all the stuff that was sent, and when we're talking about the first satellite in 1957, right, the last thing we were thinking about in those early decades was cleaning up after ourselves. Nobody thought we're going to come to this point. And when we were negotiating the Outer Space Treaty, it was largely a disarmament treaty. We really recognized, or the drafters really recognized, we don't want the Cold War to go to space. And so really focused on, there are very few rules in the Outer Space Treaty. It's guidelines and principles. And one of the rules is not clean up after yourself. And so we're in this position where if you don't have to clean up after yourself, why would you?
Yeah, I guess I'll add on and just say, part of the problem, right, is that every single thing that we launch into orbit, its fate is to become garbage. Because after the thing stops working, it just stays up there for very long periods of time, months, years, decades, centuries, or even longer. So it's very analogous to the problem that we have with single-use plastics, right? Is that we've realized that single-use plastics aren't so good and that we need to prioritize circularity with waste management by saying, hey, what can we reuse and recycle? We've figured out a way to do that with rockets, at least Elon has with SpaceX, but there is no reusable and recyclable satellite or space system to date, and so that's one of the shifts that we need to make.
And so the sky is literally falling in a way when we think about some of these objects, these pieces of space junk or space debris striking Earth. And yet, I mean, it's such a low probability event for anything bad to happen, right? So I think there's this tendency for both members of the public and policymakers alike to say, well, who cares? It's just going to fall in the ocean. And sure, we have one in a million chance of something striking someone somewhere on the ground. But I mean, why is that an invalid response? You think just to kind of dismiss it and say it's low probability?
Yeah, I mean, look, I don't think that it's an invalid response to say it is a low probability. The probability of anybody in this room getting hit by junk, there's probably higher probabilities of winning the lottery than getting hit by a piece of debris, any single person in this room. But if I said we can guarantee that there's going to be a mid-air collision between two commercial aircraft within the next, say, 5 years, guaranteed that there will be one. Well, you say, well, there's a lot of flights. What's the probability it's going to happen to me? Well, that might seem pretty low, but at the same time, it's going to happen to somebody. So I think that's the way that we need to look at this stuff, is not saying, well, what's the probability it's going to happen to just me? But somebody somewhere that's living, somebody somewhere that has kids, that has families, is going to be negatively impacted by something crashing on them at some point. That's going to happen if we don't change the way that we're doing things,
And it's not just things that fall back to Earth, it's things that are colliding in space. And so much of our life, our infrastructure relies on satellite technologies, right? And we've already seen through ASAT tests and all these smaller pieces of debris, piece of debris the size of a grain of sand actually causes, chunks, cracks in windshields of shuttle and in the cupola station. And so if one of these satellites, a commercial satellite, gets hit by a piece of debris and the solar panel goes out or something, that will affect thousands, perhaps millions of people.
And it seems like this might be the kind of thing that some folks might argue there's going to be some kind of technological panacea, some kind of technological solution, whether that's better traffic management in orbit to detect close passes and then nudge spacecraft out of the way that are vulnerable, or whether that's going to be some method of remediation up there, going up into orbit with a laser broom. I can't remember what some of these terms are. I mean, do you think that's really going to be sufficient? Because again, there's a tendency to just try to use technology here and those sorts of approaches to try to fix this, but maybe that's not going to work. It's not the whole solution.
It has to work. I mean, we have a lot of international and national laws right now saying we have to mitigate potential debris, right? The FCC just issued new rules saying if you have a satellite on orbit, you have to make sure it deorbits within 5 years of its end of life, which seems like a long time, but this is in the international level, it's a 25-year rule. The problem is we're in something called the Kessler syndrome. The more debris we have, the stuff that we have up there is going to spin around and hit other things, and then that's going to hit other things, and we're going to have lots of really small pieces of debris. We need to start cleaning up, and we need the technology to work.
Yeah, absolutely. So, I just see too many people that are or people instead of and people. It's like, oh, we're going to do this or do that. It's like, no, we need to do this and that. So technology definitely needs to be a part of the answer. The cleaning part definitely needs to be a part of the answer. And Technologies tend to come from the fishing industry, like nets, harpoons, hooks, that sort of stuff. But yeah, so we need to remove some stuff. We can't remove everything. Look, orbital space is never going to be like it was in 1956. Just like the oceans are never going to be completely clean. We have to learn how to live within the filth of our own bathwater to some extent. But we can do something to start reversing this damage. And Mother Nature is resilient. When human beings take the foot off the gas pedal, Mother Nature always seeks equilibrium. But the thing is, we're just launching 60 satellites every 3 weeks at this point. It's like we are outpacing the environment's ability to give us feedback on the unintended consequences of our actions. And that is one of the things we just need to pause and listen.
And to put a little more framing around what we're talking about, when it comes to dealing with the space environment, and the debris population specifically, we typically bucket it into three major things. There's debris mitigation, which is reducing the amount of debris we create through things like launching satellites and operations and end of life. There's debris remediation or removal, which is cleaning up the stuff that's already up there. And then a bucket, which I'll refer to as space traffic management, which is how do we minimize the impact that debris has on active satellites. So what we're talking about, things like avoiding close approaches, avoiding collisions, generally managing stuff. And of those three, the most focus historically has been on orbital debris mitigation. There's, as Michelle mentioned, there's developed international standards for how to do that. There's, at the national level, a lot of countries, including the U.S., have laws and regulations in place sort of implementing those standards for both governments as well as private sector entities. Quite a lot's been going on that. In recent years, there's been more happening on space traffic management. There's been a couple of hearings on the Hill that some of us have participated in the past. There's government policies, lots of discussions. We track stuff in space, and there's sort of focus moving on that. And then there's the remediation or removal piece. And I think that's what you were getting to Lee, where there's some ideas for the technologies, but there's also a lot of other gaps. And there's not really there's not had been any action on that piece of it.
Maybe we should adopt, I'm going to throw this out there in a really broad way, kind of the Hippocratic Oath, right? First do no harm, and I think that all those different three components are reflective of that. But do we really even know the harm we're doing per se? I'm thinking in particular about a study and there's been, I think, a couple of somewhat they aren't all out yet, but there's a study that came out recently from I believe it was a couple of planes that went into the upper atmosphere, the stratosphere, and we're looking at amounts of vaporized metals that were up there, and they found that actually there's a very significant spike in the abundance of certain metals that it's very hard to see where they'd come from if it wasn't from reentering satellites and stuff. And do you think we know enough about this aspect of the problem? Because the whole idea, like you said, is nature takes care of everything, right? It just falls back into the.
Well, so I didn't say nature takes care of everything. I said nature seeks equilibrium. And the thing is, the equilibrium state may be one where we don't survive. So the planet will keep on rotating with or without humans. Okay, so let's just be clear about that. But yeah, I guess the thing that I want to say is that there's a lot of science that still needs to happen. There aren't really places that are funding that because it's very unappealing and unsexy to study debris and all that other stuff. Like the National Science Foundation is like, oh, we're just basic science and we're this, and the DoD is like, well, we're defense. We shouldn't be studying like upper atmosphere. So everybody's like going away from these sorts of things, but nobody is actually saying this is something that needs to be studied holistically. There's what are we doing to the atmosphere with all these things disintegrating, right? Even the amount of objects, we don't understand all of the things that we need to understand about these human-made objects in space, how these things age, for instance. There's no taxonomy or classification scheme for human-made objects in space, meaning that it's like, well, if you go to the Department of Defense, there's like rocket body, debris, and like payload. Like that's the kind of classification scheme. But on a regulatory framework, it's like Vespa scooters get treated differently than trucks that have oil and gas. Oil tankers on the sea get treated differently than kayaks, right, and canoes. In space, the CubeSat is the same thing as a frickin' rocket body. It's like, that doesn't make sense. And so these are the science pieces that need to close so that we can have like scientific informed policy that can lead to sustainable practices and all that.
I think the key is that getting these studies done, and there is an act right now in the Senate, the Orbits Act, which actually focuses on, giving NASA instructions to do certain things and giving the Commerce Department instructions. We need to get this. We need to motivate people to do that and get that process started.
So it sounds kind of like what you were saying, more, but is that no one really is taking ownership of this problem per se? Who's really in charge when it comes to this problem? Is there any clear answer at all?
So that's like the cartoons where who's in charge and people like take a step back and then like there's a dog, a lonely dog that like is in front of everybody, droopy or something. That's pretty much what's happening. And the thing is, when you talk to any agency, I was at the FAA at this Commercial Space Transportation Advisory Committee meeting just a couple weeks ago, and I said, okay, because the FAA was celebrating, oh look, we hit a home record with licenses. Okay, cool. What is that doing to if people are launching 100 satellites every couple of weeks, what does that do to the environment? Can the environment carry that capacity? At what point does that carrying capacity, Kessler syndrome, So it's like, well, we here at the FAA care, and at the same time, we only do what Congress tells us to do. So that's what I hear from different agencies, right? It's like, we don't have the mandate, we don't have the this, we don't have the that. And every agency has things that they care about, and the people care about the whole problem. But at the same time, it's like, who can make the actual decisions, back to who's in charge.
Yeah, and to flesh that a little bit, so in the policy where we talk about public policy, which is how the governments decide what to do about a specific problem, and there's public administration, which is how they organize to implement those policies to carry that out. And we actually, on this question, we have a fair amount of policy on this. Every presidential administration since the Reagan administration has issued a national space policy that includes a statement on orbital debris. And over time, that has changed. So the Reagan administration was the first one to say, hey, we should think about mitigating orbital debris. And then each successive administration added a little more piece to it. Well, we should get other countries to do the same, or we should put together standards, or we should take those standards and flow them down to commercial licensing. It's sort of built over time. The challenge that we're seeing is, I would say, is a little bit more on the public administration side of, do the agencies in the federal government have the authorities and the resourcing to actually implement and meet those policy goals? A good example of this is the Obama administration's 2010 National Space Policy. It says in there's a whole bunch of debris stuff, and it says, and the NASA and Department of Defense will jointly develop the capabilities to remove orbital debris. That was 14 years ago, and we do not have a program for such now. Why? In part because it's not those agencies' job really to do that, right? They're off doing other things. They're doing national security on NASA's side. They're doing space exploration, all these good things. So the question is, if you're looking as a scholar of these issues, I'm a big believer in, agencies will respond to their mission statements and the authorities they are given, and that is just a big hole that we need to address when it comes to this question, right? Which federal agencies are responsible for looking at this problem of space environment, something like that? Because at the moment, the question is no one. It's sort of scattered among different agencies. And that's just a really big question that, unfortunately, is one of the things that Congress can resolve.
It makes sense that we're focusing on U.S. policy here, because here we are on Capitol Hill. But it does seem to me almost as if we're living in a house, multi-story house, and the house part of it is on fire, going to be on fire, and maybe we have a fire extinguisher in our room, we can blow out the flames and stuff, but the roof could still collapse on top of us because of what other housemates are doing on the planet, right? I mean, so it doesn't really seem like a U.S.-centric solution would necessarily be the right way to go. How are we going to get other people on board?
And let me add into that international context, right? Because you're right, it's not a U.S.-centric solution, but we're just talking about the U.S. because it's one of the biggest space players and has a lot of objects on orbit. Other countries are also looking at this issue. We mentioned there is this international group of space agencies that sets standards. The United Nations has put out guidelines for responsible behavior in space. And on that last question, the remediation removal, there are a few countries that have national programs to develop technologies and do demonstrations of and tests of those. Notably, Japan has an effort underway to go look at, figure out, and then remove a piece of Japanese space debris. The European Space Agency is also doing the same thing with a piece of European debris, and the United Kingdom is looking at soon initiating a program of their own, which is great. Those are hopefully going to demonstrate this is possible in the technology of the problem. The question, I'll leave Michelle to flesh this out. The issue is you can only really touch your own stuff in space. and you know, those countries don't, while they have some stuff, they don't have a lot of the debris that's out there.
And when you think about the actual technical capability to remove debris, or whether we're bringing it down into the atmosphere or whether we're going to move it up into what we call a graveyard orbit, that is a rendezvous and proximity operations that can also be very nefarious. And so there's a lot of hesitancy with accepting the fact that, okay, wow, you now have the technology to get really close to my operating satellite, and that makes me really nervous. But we do have, under the Outer Space Treaty, we have very few rules, but one of them is if you launch something into orbit, that object is yours. You maintain responsibility and control over it, and nobody else can do damage to it or move it or do anything. This is something, space is, the fundamental precept of space law is freedom of exploration and use for all. So you can go and do whatever you want, you can leave whatever you want in space as long as it's not a nuclear weapon. And it's very hard under this sort of rubric of freedom to make anybody be responsible. The only provision in the Outer Space Treaty that we have is something called due regard. So you have to conduct your activities in space with due regard for the corresponding interests of others. Now that sounds like it's really useful, right? Because due regard means being considerate, responsible. Due regard is a balancing test. So there's no fine line that says, oh, if you hit something or something hits you, this is the rule, you're liable. And we know from, how are you going to go and figure out exactly what happened when we're talking about little pieces of debris that we can't track? And so it's really the other problem from a legal standpoint is due regard is a huge, if we open that box, imagine what people will say. Oh, you're not showing due regard for my space station because you came too close. We've already had China, interestingly, in a couple years ago, sent a note verbal to the United Nations as a formal notice saying, hey, United Nations, under Article 4 of the 5 out of the Outer Space Treaty, I wanted to let you know that there is a phenomena that is dangerous to humans happening in space right now. And that phenomena was Starlink. And so it was really interesting that the Chinese were anxious because the Starlinks were too close to Tiangong, their space station, but they didn't use due regard. They used this Article 5, which is protecting humans in space. So due regard is really sort of an untouchable concept that we have to wrap our arms around.
So one of the things I love, everything that Michelle and Brian said, I think adding to that, as a technical person that cares about, the policy and that sort of thing, I would love to see a different interpretation to harmful interference, in UN treaties and conventions, to go beyond physical damage, to also incorporate environmental damage, economic damage, and these sorts of things. I mean, when satellites have to spend propellant to move out of the way of junk that somebody else created because they blew up their own satellite, that's an economic issue. It's an operational cost and burden. And the other thing, too, getting to what Michelle said with, launching states are the ones responsible, for these objects, and you can't just transfer that, is that, it says, if you launch an object in orbit, you're responsible. Procure the launch of an object in orbit, or if your territory facility launch an object, you're responsible. So sometimes, and here's where it gets really complicated, right? It's like, if all of a sudden, and I think Ryan Guglietta from State Department was complaining about this recently. It's like, in this day and age with globalization, if I have a satellite that, let's say I work for Planet in San Francisco, I have one of these satellites where there's hardware that came from Mozambique and another piece of hardware that came from France that are part of that satellite, and then I launched it with India's PSLV. That means that for sure the United States and India are responsible for that object for its lifetime. But what about these other parts that got built in different places now that different satellite companies are existing globally? Like, so at some point, is it just everybody's response? Like, how does that get divvied up and that sort of stuff? Because what we'd love to be able to do, right, is apply things like maritime salvage laws, something analogous to that in space, like where you have pure salvage and people could just get compensated for just removing and cleaning stuff, or contractual salvage, right, where people get hired to do that. And right now, if it's between different launching states, it's a no-go, So that's part of the issue.
Is the UN the only way to really make this happen? I mean, is there some kind of bottom-up grassroots thing people can do? Like not using plastic straws to help the sea turtles.
So the United Nations does not have any power to force countries to do anything, right? The United Nations is a discussion body where countries come to talk about issues like these and others, and sometimes within that body they come together and agree on a new treaty or a new agreement. These discussions have been going on within the United Nations for quite a long time. The treaties that Michelle mentioned came out of the UN decades ago, back in the beginning of the space age, and some of the existing international norms and standards on mitigation have arisen out of more recent discussions at the UN. But at the end of the day, states are sovereign, and that's really one of the big challenges here. Roughly speaking, about 30% or so of the debris objects are U.S., about 30% are Russian, and about 30% are Chinese if you count by numbers of objects. Getting those three to agree on anything in the current is not getting any easier, let's put it that way. And as we said, it's not like the U.S. can go grab somebody else's stuff, right? That's a core part of international law. So those are some of the dynamics that are challenging to work through. I can say that many countries do care about this issue. More and more are putting in place their own national policies and regulations for debris mitigation. And as I said earlier, there's a few that are funding remediation development technology demonstrations. We're just not seeing the whole-scale action happening on removal.
Yeah, go ahead, Michelle.
I was just going to say, and we also see countries that are outright ignoring the issue. In November 2021, the Russian ASAT test created a debris field. Again, from a legal standpoint, I'm thinking ASAT tests really aren't showing due regard for the corresponding interests of others, of anybody on Earth, right? But as long as we have testing, people not just leaving their stuff up there, but actually creating debris, it's very hard to reach agreement.
I do think that there is the possibility of a bottoms-up approach. It's very challenging for that. There certainly could be countries that behave sustainably to kind of show people, hey, this is the way you do it, this is what you could do. You could have countries that start developing reusable and recyclable satellites, for instance. You could have countries that say, I'm going to pay somebody to remove one of my things when the thing doesn't work anymore. But when I think about, the United States maybe leading that sort of stuff, I think some of the most congested areas right now in LEO are the sun synchronous orbit altitude, right? And the thing is, if the United States said, we're going to hire people to have like a space garbage truck cleaning equivalent in that orbit regime, there's nothing that stops these other countries from still polluting it, right? So it's almost like you can say, well, it's almost like we all live on this one street, we're all neighbors, and all of a sudden it's like, well, I'm going to take it out of my hide to just sweep the street, except that you have somebody across the street that's throwing their banana peel in the freaking curb and that sort of stuff, right? So it's that sort of thing. So it takes a lot of goodwill and the hope that other people will see that goodwill and kind of add on to it for this sort of bottoms-up approach to.
It's almost like space is the global commons, even.
Imagine.
Tragedy of the commons. Yeah. And so it feels like we have to approach this with a mixture of skepticism about what can actually work and what's feasible, but also optimism that something has to be done, something has to work. It's such a pressing problem and only getting bigger every day. What do you think? What do you think should be done? What do you think policymakers here in this country can do? We've already talked about some of it, or maybe the way to flip it around is what is standing in the way more than anything else from more action being taken?
it's that leadership, you know, and everyone, as Marie was saying, everyone's stepping back when we bring this up. And so again, you know, it's identifying, giving an agency in the United States the actual responsibility, and that's something that Congress can do, right? Say this is your responsibility. Hopefully, it comes with some money, and then we actually get a unified process for this. And to the point of, yes, it is very painful to be the leader in this kind of a field. The United States has proven to be a leader in space many, many times in the past, and this is just another one where we really have to step up, or else all of humanity will suffer.
Yeah, I mean, I completely agree with everything that Michelle said, and I'll say that, for me, it would take agencies willing to do something that's going to draw some attention, where people would be like, well, why are you doing this, that, or the other, right? Just do it and kind of ask for forgiveness kind of stuff instead of permission, and just like be bold and do these sorts of things. I think it's going to take more of that sort of behavior to see these things move forward. And to Michelle's point, I mean, if the United States were taking these steps, the United States still has a lot of positive influence over many countries around the world. And 9 out of 10 people want to do the right thing, and they're just hesitant and reluctant. And I think if the United States would just do that others would definitely join and follow for sure.
Morby, you've talked before about a circular economy in space. And I think some of these ideas have kind of cropped up. That you've mentioned different aspects of it, but could you kind of unpack that a little bit more for me and just explain what do you mean when you talk about a circular economy?
Yeah,
in space?
so specifically when I talk about a circular economy, I just mean an economy that's in a circle. Don't you get it? It's just no. I'm joking. No, so I never come up with anything new. I just borrow other people's stuff, right? And so in investigating this whole idea of pollution in space, I've been looking at waste management principles and these sorts of things. And linear economies, and when we talk about linear economy or circular economy, we're talking about waste management. What is the end state of the products that are developed in that specific kind of line of economy? And right now we have a linear economy in space, meaning everything that we launch, like I said, is destined to be trash, and which is why we just, like single-use plastics. Oh, it's like, okay, the water bottle is up in Leo, so we're just going to throw another kind of thing filled with water, and then we spend that, and then it's, empty, and we launch more. So circularity means that you prioritize waste management by saying, hey, I'm going to design this thing with the intent that when the thing dies, it can be reused, it can be repurposed, it can be refurbished, that sort of stuff. And if it has to be single use, then the disposal has to be responsible. Right now, even with the 5-year rule, the 25-year rule, by and large, people are looking at putting things in Leo because to adhere to these guidelines, if they just don't do anything and abandon the object, Mother Nature will remove the object in the 5 years, right? So it's like, okay, I'm going to choose. That's like saying, look, you have to make sure that your front porch is always clean. Well, I'm going to choose to live in a really freaking windy place so that the trash gets blown away by the wind eventually in 5 years. Mm-hmm. That's the behavior of people just trying to crowd Leo at this point with this kind of rule. So responsible disposal would be like intentionally removing the object, not just abandoning it, but intentionally removing it, but at the same time designing it out of materials that aren't polluting the atmosphere in the process of,
Got it, okay. People talk about, with these sorts of global environmental problems, they talk about tipping points a lot, about red lines or thresholds that you really shouldn't come too close to or cross because, these complex systems can behave non-linearly. Like you tilt back in your chair and you tilt a little too far and all of a sudden you're on the ground. Do we have a good sense, do any of you have a good sense of what some of those sorts of tipping points or red lines might be for the orbital environment?
Well, so here's the thing, right? So we talked about Kessler, I talked about like orbital carrying capacity, and at some point these orbital highways become unusable, okay? What does unusable mean? Some people say, well, space is big, so we have all, if you look at that stuff, there's plenty of space to pack more satellites. Yeah, you're not wrong. But I've had colleagues at NASA say, we are being significantly challenged in getting science out of our satellites because we have to maneuver so often. We can't get to the ground targets that we want when we want them because we have to alter our trajectories all the time, getting out of the way of junk. That is space becoming unusable. Because if the purpose of the satellite is to provide images at a certain time with a certain frequency, or to provide services like communications that are dependable, but you have to alter that because of all this unmanaged traffic and junk, then space becomes unusable for the purposes that we want it to. And I think we're already there, man.
Mm-hmm.
Everybody's like, what's the tipping point? It was like 10 years ago. The tipping point is, we're past that. Now we have to actually take some action. But everybody that I talk to is like, dude, what's the next catastrophic thing that we're waiting for? The next catastrophic thing is, it's like, yeah.
It's interesting, many people have heard of Kessler syndrome and know about that. Very few people have actually read Don's original paper that he wrote with Burton Coe-Perlet back in '78. And it's fascinating because they coined this term, this notion of a cascading collision happening in space. Essentially, more stuff we put up there, there's a more chance that it'll collide with itself and generate more debris faster than the atmosphere cleans up, right? That's the cascading collision I talked about. What's interesting is that the really bad thing they talked about was that at one day, the human-generated debris might pose more of a risk than the existing naturally occurring debris. That happened a long time ago, right? We don't even talk really these days as much about micrometeorite impact. We talk about human debris impact. So the thing that Don Kessler talked about as being really bad has already happened a long time ago. Now, the bigger question is, many people ask, the cascading collision scenario he talked about, is that going to happen tomorrow? Or is there going to be an event that switches that on? We were talking last night at dinner about the movie Gravity that came out, which, in our community, there was a big debate over how good that was. On the one hand, many people saw it. It was a very entertaining movie. Many people know about debris from that movie. The challenging part is that the physics were not great. And it described a scenario where there's one event and in 5 minutes every satellite is gone, which is just not what's going to happen, right? This is a much slower process. So it's hard. It's hard, right? Because you have to try and calibrate between not being realistic about what's actually going on, but also trying to give a sense of urgency. Because you say, well, the problem's going to be really bad in 200 years, right?
Yeah.
I mean,
it's not going to motivate change, right?
Yeah, but we are. I just want to really reiterate, we are at the tipping point. We have passed.
Or past,
I mean, we've
yeah.
heard from both of them.
Yeah.
We have passed the tipping point, and now is the time to act because it's not if this happens. It is going to happen, and we're seeing it more. We're seeing close calls between satellites more and more, and there's only so much that the Air Force can do to manage that traffic, and we can do very little about those minuscule pieces that can cause tremendous damage because they're traveling at 17,000 miles per hour. I hope that was right.
In American, yes, that's about
Okay.
Yeah. Absolutely.
The lawyer that's surrounded by two scientists.
Yeah.
So it's the tipping point is now. I mean, we've long passed it, and we need to wake up to that. The sky's not falling, but it is.
And Michelle, if I may, to follow up on that a little bit, while we're thinking of kind of science fiction or futuristic scenarios, shouldn't say sci-fi, but there's plans to have people go to the moon. Some people want to go to Mars. We're extending our human footprint one way or another out beyond the Earth and out into cislunar space and interplanetary space beyond that. So much of the space debris problem seems to clearly, obviously, for good reasons, be focused on Earth. But are there any things we need to worry about, for folks on the moon? Or
Oh, absolutely. I mean, right now there are more than 110 sites on the moon with evidence of human activity, right? And if you think back when India announced it was going to land on the lunar South Pole, what happened? Russia said, "Oh no, we can do it before you," and so they just sent a rocket. And what were the chances that that rocket was going to soft land on the lunar South Pole before Chandrayaan-3? Not very good. But Russia just felt like, "Oh, we're going to send it and see what happens." We're now sending stuff to the moon just because we can. And we're just creating more and more debris. I did want to say, with respect to the circular economy, so my organization, For All Moonkind, is focused on protecting and preserving heritage sites on the moon. And like I said, there's more than 110 sites on the moon. We don't want to preserve all of them. We need to have a hierarchy. But I approached Harrison Smith, Apollo 17 astronaut, and said, "Hey, are you on board?" And he said, "No." we need to recycle that stuff on the moon. I don't, it's so expensive to get stuff up there. We ought to be recycling it, not protecting it. But we really need to think about, it is very easy to send a locket of hair or ashes to the moon. Do we really think that that's the way we ought to behave, especially looking at low Earth orbit? And we can't even imagine the repercussions of having a lot of junk on the moon. And so what we do in low Earth orbit is really going to be the framework for how humans behave in space. And that's going to cover the moon, that's going to cover Mars, that's going to cover any new planets that we find habitable.
If I can just add to that, we've been talking about these existing international standards and frameworks for how to properly dispose of things in Earth orbit and how to mitigate debris in Earth orbit. Unfortunately, those aren't really all that useful for lunar and cislunar because the orbital dynamics, the physics are radically different, right? There is no atmosphere on the moon that is going to help pull things out of lunar orbit. The perturbations are very different. We don't really know what a disposal orbit in lunar orbit would look like. So I'll give a shout out to a colleague of mine, Aerospace Corporation, Joe Gangstead, has done a lot of work trying to flesh this out. We actually have a publication that came out end of last year sort of laying out some of these differences. But there is a huge amount of work that needs to be done to adapt this concept of debris mitigation, post-mission disposal from the existing Earth orbit context to also include how to do it for lunar missions. Because as we put more stuff towards the moon, there's already been a couple of examples of lunar spacecraft that have come close to colliding, right? They've had to do an avoidance maneuver. And you definitely don't want that to start happening there in addition to happening around the Earth.
Yeah, I'll say one thing just to kind of close this off, right? It's like if all of us right now could take a trip to Mars, for instance, be on the surface, would see Matt Damon. No, we wouldn't see Matt Damon.
He's still there?
Yeah, he's still there, sciencing it up. Anyway, if we were, on the surface of Mars, what would we see? We'd see some dead rovers. We'd see some broken heat shields. We'd see some parachutes in the Martian wind. We go to the moon. We'd see some buggies. We'd find some bags of astronaut poop and that sort of stuff, right? And it's like the way we explore, it's always to the detriment of the environment. It's always like, well, look, the moon's big, so kind of who cares? Mars kind of big, like who cares? Oh, it's success. We sent something. We can change the way in which we explore. We have to change the way we can. People say, well, it just costs more. But people are thinking very myopically, right? It's like they want the success under their term, under their this, under their whatever, to whatever cost. But the cost that you get for sustainability, that's the right cost. That's the right price. Whatever it is for us to be able to keep on exploring sustainably is the right price.
With that, I'm going to cede the floor to Clara, my colleague, for some closing remarks.
Well, I just want to thank our panel and our moderator and all of you for being here. I think this was a totally fascinating and useful conversation, and we'd love to keep it going, so please stay in touch with us if you would like to talk about any of these issues more, and thank you again for coming.
Thank you.